All right, so this type of testing, we do what's called matched pair testings. It's going to look similar to a two-sample t-test. However, the two groups are no longer independent of each other. Um, so what you're going to see uh, is there's still this idea of independence, uh, but basically each individual or each observation is in both groups. So it's pretty easy to spot a matched pairs. So, uh, for example, you see it happening um, right here. So these examples, maybe before and after a treatment. So they take a look at cars before they do a treatment of some kind of fuel additive. I kind of mentioned this earlier. A big one that you see a lot, maybe pre and post test. So students take a pre-test, they go through some kind of special training, and then take a post-test. So you see that the students are in both groups. One thing, if this is confusing you, I apologize. I think I put the holes on the wrong side of your note sheet. So the holes are backwards. I apologize. So flip it over. We're going to start with the matched pairs t-test, not the, we'll go to the interval after that. So some of the details. Basically what's going to happen is we're going to define the differences as mu sub d. So basically we're going to create another list of all the differences. And once we have that, we're going to conduct our test. So basically you're going to conduct a t-test only on the differences. So yes, there are two things, but it's not a two-sample test because really we're not able to compare the two groups separately from each other because they're no longer independent. Um, and then the degrees of freedom here is going to be equal to the number of pairs minus 1. So the conditions for us, we still want random. You still want uh, you still want more than 30 differences, or you want the differences to be normal. And then here, the third group here, we want each individual to be independent. So the groups are no longer independent, each individual is independent. So, one student's performance on the pre and post test isn't going to affect the next student's performance on the the test. So when we go to the test statistic, um, typically it's still going to be a t-score. I couldn't imagine there'd be a z here, but it's still your observed, so we'll call d bar. So d bar is the average of the sample differences. And so you really the calculator's going to do a lot of work for us, but we'll just write in the formula. Then we have what should be the average of all the differences together. You know, the standard deviation of the differences. Oh, excuse me. I don't know why I'm switching from uppercase and lowercase, but so we do the standard deviation of the differences over square root of n. So it's a very, very similar formula. And again, degrees of freedom equals number of pairs minus 1. Right? A lot of the things are going to remain the same in terms of what we write down. So, can taking lessons on playing chess improve your memory? So the USA Junior Olympic researched something, blah, 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 described a study in which sixth grade students who had not previously played chess took lessons and played for 9 months. Each student took a memory test before and after the program. So you see a pre-test and a post-test. This is one of those kind of dead giveaways. This is a matched pairs t-test. And we can see a quick 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 students that were in the group. So I do 12 minus 1. That means there's 11 degrees of freedom. And now to conduct the test, what we want to think about um, is we're dealing with the average of the differences. So one thing to consider, if there is no difference in pre-test and post-test or before the program, after the program, then those differences should average out to be 0. Some students will do better, some students will do worse. Um, if each, if they're trying to see uh, each, if we look here, can chess improve your memory? So at that point, if it improves, then the post-test should have the higher scores. So what that would tell us is that when I subtract pre minus post, right? So this red, you don't have to necessarily write it. So pre minus post, if the program really does improve memory, that should be a negative number. So in other words, we should be, the average difference should be negative or below 0. So what I'm going to pause here, put the pretest in list 1 and the post-test in list 2, and then I'll show you a trick we can do to set up our test very quickly. So pause the video, go ahead and put that data in your calculator. So right now what I've gone ahead and done is I've put the pretest into list 1 and the post-test into list 2. And now in list 3, if you go up to the top of list 3 and you do L1 minus L2, so go highlight list 3 and then type in L1 minus L2, you'll get the following scores. So you end up with negative 340, negative 180. So it looks like the first two students both had improved scores. Negative 210, negative 100, negative 100, negative 225, negative 90, negative 225, negative 240, negative 55, 35. So here's one student that had a better pre-test score than post-test score. And then finally negative 5. So that last student in the group had just a little bit better average. So really what we're going to do here, guys, we're no longer doing a two-sample test. We're doing a matched pairs test. But we're going to take this list right here, your list 3, and you're basically just going to run a t-test, right? We're basically running a t-test with list 3 to see if it averages 0. If the average, really, you want to think about it this way too, is significantly different than 0. And I guess in this case, since we know it's less than, that's really what we're doing right there, guys. Again, this less than 0, right? If the students did better, then their combined score, right, start minus finish, should be negative, which is the case for most of these students. A few students it was barely better. A few students it was significantly better from the looks of it. But we need to run the test to be sure. So here's our t, and then so go over to your t-test, and we have the data, right? So again, you don't have to write what I'm writing in red right now, but we've gone to the t-test. We're going to select data, and then the mu sub 0, right? The status quo would be that it is 0, that there is no difference. The list, here's where you got to be careful. We put our data into list 3 is the one that we want, so make sure you change that. Frequency is still 1. We don't have a frequency list here. And then we're using less than mu 0. We're using less than 0. So again, you don't have to write this stuff down, but that's just so you can see the calculator. So my t value, so my x bars, there's your d. The x bar here is that d bar that we mentioned before. Put the 0 in as a placeholder, right? Mu sub d is 0. Right? You see it right there. That value is going to go right there. And then your Sx, 109.74 over the standard deviation of 12. So that equals negative 4.56. We'll use alpha at 0.05. Our p-value is 0.0004. 0.0004 is definitely less than 0.05, so we'd reject the null in favor of the alternative. So here, evidence suggests the post program scores are higher. This indicates the program helps with memory recall. One thing we got to make sure that we go back and we fill in are the conditions. So I kind of didn't leave myself much room here. I'm going to erase the red part here so I can go back and stick my conditions in here. Just very quickly, again, we didn't have to put it at the beginning. We can put it wherever. So each, right, we want to make sure we have random. Differences, we don't have a lot of them, but if we did check a histogram, the differences are normal. And here, each individual is independent. Individual is independent. Sorry, we're not a room. Individual is independent. So one student's scores don't affect the next student's score. So there's your conditions for this particular test. Now, matched pairs interval. This would just be, again, a matched pairs t-interval. And so here the conditions are the exact same as the matched pairs t-test. And here's just a good chance to remember how do you approach the formula here for us, going back and reminding you how to do those intervals very quickly. And so what that'll look like is that d bar plus or minus, we have a t star, and then the standard deviation of the differences over the square root of n. So it's a lot like our, if you recall, the t interval, kind of a side note here, that was x bar plus or minus t star, and then s over square root of n. We're just putting that subscript of d bar as the average of the differences, or the standard deviation of the differences. So here, to determine whether or not caffeine dependence was a real phenomenon, they conducted this study. So take a moment and put that into list 1 and list 2 and create your difference list in list 3. So I took a moment, I put all that data into the calculator, and the differences that kick back to me, 80, 22, 17, 131, negative 29, 3, 23, negative 1, 20, 340 minus 391, negative 51, and then negative 3. And so what we want to do is we're going to set up, let's just take a look at how you would do a matched pairs t-interval. So matched pairs t-interval. There are 11 groups there, so we have 11 degrees of freedom. We don't have to worry about hypotheses, the conditions. We want random. We want the differences to be normal. And we want each individual to be independent. So the groups are no longer independent. So again, each person was in both groups. They were given a placebo and they were given the caffeine pill. Each individual is independent. So if we go to our test, we're going to do a t interval. Right, so over here in red, we're doing a t interval. We're using data. We're going to use frequency, or not list. The list is list 3. Again, the difference list. We still have a frequency at 1. And then I'm just going to use a confidence level of 95. Calculate that. So our x bar was 19.27 plus or minus. We got to go get that t star value. And we had 49.64 over the square root of 11. And my interval, negative 14.07 to 52.62. All right. So what happens here is we now write our sentences. A good chance to remember how to write these sentences. So we are 95% confident the true average difference in caffeine versus the placebo is in the interval negative 14.07, 52.62. Because 0 is in the interval, it appears there is no difference. So because 0 is in that interval, there appears to be no significant difference. All right, so the last thing I need to do is go back and grab that t star value. And what I can do, 11 degrees of freedom, and go to my t-table. So go 11 degrees of freedom, and then go to where there's 95% confidence. So I want the t star for 11 degrees of freedom, 95% confidence level. That would put me, hard to see with all this, looks like 2.201, so 2.201. And there's how you would set up a matched pairs t interval.